Hello, everyone. Really happy to be here in New York City. Today, I'm going to share with you about a carbon measurement tools I built to measure emissions from LLMs. And I'll be talking about my journey to build that tool, as well as some of the learnings along the way. So one thing that happened in March 2025 is that ChatGPT released a new version that allowed people to create images right from their chat interface, their web interface. And about 170 million images were generated in about a week by 300 million users. It was so popular that it overwhelmed their system, and Sam Altman had to roll back to the previous version because according to him, the GPUs were completely overwhelmed. And to go down further into this story, the feature allowed you to create an image from different styles, including a style from the Ghibli studio, and it became so popular that everybody wanted to try it out and play with this new feature. It became viral, and about 5 million images were generated per hour until the feature was shut down. And this was just for purely recreational use. And if you consider that one AI image takes about as much energy as one phone charge, you get an idea of the scale of the amount of energy that was spent just by using this feature. So we know that energy demand from data centers is set to increase significantly by 2030, more than double by some estimates, according to the International Energy Agency. And this is a trend that's going to increase and continue. I would like to share with you my journey and how I got involved with this in the first place. So AI has been around for a very long time, and I had a chance as an intern right out of college in France to work on a project to classify handwritten characters that were used by the post office for recognizing automatically the postal codes. Very interesting project. That was the early days. And that was in the mid 1990s. And then I moved on to work for Hewlett-Packard for a while. And I got involved with a large open source project called OpenStack, with about thousands of contributors, looking at different ways to automate and provision cloud infrastructure. And then I went to work for a while for a company as a product manager called Quali that was focused on data center automation as well as DevOps. And it was all about being more efficient at removing resources that were not used or no longer used in the testing phase, so removing waste. And back then, the focus was on cost reduction, but it was really also about being more sustainable. And eventually, a few years ago, I launched my own consulting company, IT Climate Ed, and I started to really be focused 100% on how to be more sustainable with the usage of digital technology in all aspects, including artificial intelligence. And I started launching a few courses and I created a few courses, and my students were asking always some of the same questions, and I had to provide some answers. One of them was, will AI benefits outweigh its environmental impact? So is it just a real concern because AI will have so much benefits to help out with solving the climate problems that we shouldn't worry about its environmental impact. And then we just talked about data center energy growth, but really how much of it can be attributed to AI. AI is not the only technology that's being used in data centers. There are cryptocurrencies as well as everything that we've been using up until now, social media, email, etc. So it's also something that's really difficult to quantify today. We just know that AI is going to contribute significantly to the upcoming growth, and especially Gen AI. Now, how models compare also in terms of energy efficiency? And question is for training and inference. If you have the choice, which one should you pick? How about the energy efficiency that we're seeing more and more with many upcoming models? We've seen the DeepSeek model being much more energy efficient earlier this year. And by itself, will energy efficiency be enough to solve this energy crisis? Just like we've seen in the internet, in the early days, we were worried about energy efficiency, and eventually it became a non-issue with the adoption of cloud technologies and virtualization. And if you look at, in particular, at end users, how much carbon emissions do you emit by just conversing with a chatbot? And this question also has a pending question, which is how much the energy intensity varies by task type and complexity. It's not always the same. So looking at all those questions, one thing that became clear is that the training, if you compare the training energy consumption versus the inference, which is the usage, inference and usage are about 65% versus 35% for training. It's a little bit counterintuitive because training is a one-time, very, very intense task that can last for weeks, sometimes months, and very compute intensive. But inference has the law of numbers behind it. And if you look at just ChatGPT as an example, we have 400 million ChatGPT users, and the estimation, again, according to the IEA report, is that each query consumes in average 2.9 watt-hour. So that's the equivalent, as a daily power equivalent to 33,000 US home in terms of energy consumption. Now, these numbers has to be really taken with some caveats because we don't really know, ChatGPT being a closed system, we don't really know for sure what's their energy consumption, and also it's very difficult to have an average for this. So the next question is, if you look at these really large numbers here about inference consumption, can we change how people use LLM? People have been right now experimenting for the most part with all these, how to use these chatbots. And for some reason, we are being very polite with the interactions as if they were real people. So we use please, we use thank you, as if we're anticipating that some point in time in the future, they would become taking control, and you would have to be very, very polite with them to please them. But right now, it's really not the case, and it's a big waste of tokens and energy. So just to recap, token is just a chunk of information, and for the sake of a text conversation, it will be just about 4 characters that eventually get converted into numbers and then get sent for computation in the neural network. So you see in red all the wasted tokens that could be much more efficient if you just, for the exact same request, which is tell me about renewable energy sources, just simplify the sentence by saying list renewable energy sources. So here you get, we get about 40% overhead just by being polite and nice to the chatbot. So before you can think about influencing how people behave with these LLMs, you have to look at providing data and how you would go about measuring this information. So there are many tools that are available out there to estimate AI emissions. And when I did my research, I tried to categorize them in different sections. One of them is by role. So if you're a product manager and your goal is to select a model for training phase, then there are some tools like the machine learning, CO2 calculator, or the green algorithm that are available. And then if you're looking at selecting a model also based on their inference energy consumption, then you would look at the AI energy score or Ecolog ITs. Then another role would be you're in an enterprise and you're a sustainability analyst. And in this case, what you're concerned about is having dashboards with the carbon footprint of all your current projects by different teams. And here the go-to tool would be to use cloud dashboards, and as well combined with carbon accounting platform. If you're a developer, then you want to look at how your current model and maybe machine learning algorithm can be improved, and you want to include some Python libraries such as Carbon Tracker and Code Carbon into your code. And finally, if you're an end user and you just want to estimate your inference emission when you're interacting with popular tools like ChatGPT, Claude, and Llama and others, then I couldn't quite find a good solution. And that's where I decided that I'm going to build something that I call AI Watch that would be very focused on the end user experience. And here I wanted to also provide some interaction that would be real time. So you have a feel as you're conversing with the chatbot on what is going on with your energy consumption and carbon emission. I also did not want to restrict myself to just open source models. There are a few tools out there that have tried to do an embedded reporting for specific open source tools that are in controlled environment. Here, I wanted to really support the LLMs that everybody is using, even though they might be closed models. I wanted this tool to be educational as well. So I wanted to build something that would provide not only data, but also potential actions that you can take to be more efficient, just like I showed in the previous example. This tool also should be private and secure, which means I wanted to minimize the amount of private data that would be collected and actually have no private data in persistent storage, and also not necessarily use secret tokens or API keys. So make it very simple. And finally, I wanted this project to be open source so that everybody can be invited to contribute. And I'm going to talk about that some more a bit later on. And that's really the way I feel this project can scale as well. So what's the experience when you're going to use AI Watch? The first thing is you download it from the Chrome Web Store. So very simple step here. And then all you have to do is start interacting with your chatbot, just like you see on that screen here. And you will see a pop-up window that's going to display your number of tokens, input and output tokens, and I'll come back on the definitions of those. But input tokens are essentially the number of tokens in your conversation when you start asking for a question, and output is the reply from the chatbot. I'm getting some information about your emissions, as well as a comparison to the amount of miles driven. And then you have a shortcut available to get to your admin information and configuration parameters. So here you have a number of parameters that are relevant for the calculation: power usage efficiency from the data center, which is a unit that's the overhead power that's used for cooling all the server's equipment. Number of characters per token. So we talked about this number, the token being about 4 characters long, but it's an average that you could change and adjust. And then you have also the carbon intensity of the grid that is different by geography, and some values about the token intensity for input and output. And again, these numbers are really estimations, because OpenAI doesn't disclose those numbers as of now, but eventually maybe they will, or there will be some open source versions of ChatGPT and other closed models, so you can adjust those numbers. And finally, just to mention about the repository, so it's mostly front-end development code. You have HTML, CSS, TypeScript for the backend, and again, very simple structure that everybody can access and view. So if you look at the system flow on how this estimator works, you start with your ChatGPT interface, and then we look at the changes that are happening. So document object monitoring. And if there is any change, so a conversation is happening, then you start to estimate the number of tokens. This is the first calculation. Second calculation, you look at, after one exchange, we look at how much emissions, how much energy and how much emissions were generated. And finally, we display that on this pop-up window. And from the admin dashboard, you inject some parameters like the number of characters per token for the token estimation, and the PUE, grid intensity, and input and output energy intensity for each token for the emissions of the calculation. So the actual formulas are very simple. You don't need to have a PhD in data science to understand these. The first step is to calculate the number of input and output tokens. And then the second step, you calculate the total energy during one conversation exchange. And that's just multiplying the power usage efficiency of the data center by the energy of the input and output. And finally, you convert that into CO2 emission using the carbon intensity. So in yellow, you see all these parameters that are retrievable from the admin interface. So another thing that I wanted to share is that as part of my product development journey, I did use an LLM myself. I used Claude Sonnet. Back then, it was sort of considered the more advanced. Obviously, these models are constantly evolving, but I wanted to use also an LLM that was not necessarily ChatGPT, because ChatGPT was sort of my test ground, and the first one that I had targeted for this measurement tool. So I did use pretty efficiently the LLM to frame the problem and look at different solutions, evaluate different solutions. And then very quickly, you are able to do prototyping. And prototyping, the experience was very impressive at the beginning. So without too much prompting, the LLM will start generating codes, hundreds of lines of codes. And this is pretty much what nowadays you call vibe coding. So you're very hands-off. I'm not a developer myself by trade, but I was able to use that code and start testing it and start seeing that, there were some things happening, but it wasn't quite working. And then the debugging started. And I saw here how things are not quite there yet in terms of getting a solution into a working product. So it took some time for me to figure out that I had sort of a law of diminishing returns, plus I was not really preaching, I was not really being very efficient in my work, supposedly spending more energy on these chatbots than I should have in the first place, which was sort of the whole point of this project. So eventually I decided that I'm going to focus on hiring a developer. And for that, I created a product requirement document. And again, it was very useful to have had these previous brainstorming with the chatbot about the project and the scoping of the project. And also writing the PRD was also very effective with the chatbot. So eventually from this project proposal, I was able to hire a very good developer who did the project in a couple of days. And eventually, I also used the chatbot to create the framing of the project in GitHub for open source contributions. So overall, a very good and interesting learning experience. And I saw, both the limits and the possibilities of those tools to create a project that eventually can be used pretty effectively. So some of the challenges and lessons I learned from this project are the fact that obviously we have a big transparency gap. And right now, all those models are closed. The one that I have selected in the first place were closed. So ChatGPT, OpenAI are not disclosing their token energy intensity. And so we have very limited visibility as a result, and making a lot of assumptions. So in order to refine those estimates, we'll need them to disclose more information. The other thing that we don't know is about the infrastructure. And two things that are important here are the carbon intensity and the power usage efficiency of the data center. So we don't really know when the inference is being run. We assume it's probably close to where the user is located, but this is obviously a very high level information. The other thing that was hard is to deal with real-time information. And if you want to have something that is available right away as you're conversing with the LLM in terms of displaying the information in the pop-up, you want to minimize latency. So it means reducing the complexity of the calculation, as well as limiting the information that you would retrieve from APIs, for instance, counting the code tokens or retrieving maybe real-time grid information. I didn't do that, and at least so far, it's a compromise between complexity and simplicity and response time. The other thing that was quite challenging was the browser integration. So here I used Chrome, and the problem obviously is you deal with versions that are changing both on the chatbot side. So OpenAI already changed completely refresh their web interface between the time I developed in December and now. So we had to fix the plugin. And the other thing is the browser itself, browser version might change. So it might also break the plugin. So it's sensitive to these types of versions and update. And you have to keep track of them. The other thing that was also and is a challenge is the fact that different tasks have very different energy profiles. For instance, reasoning task versus creating an image versus just a simple conversation may consume a lot more or less energy. And you have to sort of take this into account when you're estimating energy then emissions on a task-by-task basis dynamically. And so the key learning was really about setting the right level of expectation. We are looking at an educational tool, so it's going to be mostly about estimation and not measurement. And this is the key here to make this plugin successful, in my opinion. So in terms of impact, we are looking at different things, and one of them was how about if just 1% of the users starting to adopt energy efficient prompting as a result of viewing this information and viewing nudges about what they could do. And you could avoid, potentially using the numbers that I shared previously, about a 40% change in energy efficiency. You could avoid up to 700 tons of CO2 per year. Obviously, these are high-level estimates, but we're talking about fairly significant impact, especially if you consider that it's not just about ChatGPT, but it also could be Claude, Gemini, Llama, Copilot, a lot of other very popular chatbot tools and LLMs that are used already by millions of users. And finally, it's bigger than just energy and carbon emissions. We're looking at especially water consumption that you could save, knowing that an average data center, about 100 megawatts, consumes about 2 million liters of water per day just for cooling, and very often in drought-prone regions. The other impact could be about promoting more transparencies as more users require visibility to their consumption and demand both energy labels as well as start pressuring vendors for more disclosure. And today, vendors have no incentive to disclose their energy emissions because they want you to consume more. More tokens means more subscription dollars, but eventually, this could change. And the other aspect is that if these were adopted in enterprise, these type of tools, then at a team level, you could have best practices to be more efficient from a cost standpoint as well as an energy standpoint. It could result in internal policies at the organizational level, and then some industry-wide standards at the enterprise level. And industry-wide standards, we're talking about things that are starting to pop up, like the AI energy score by Hugging Face, as well as the Green Software Foundation is working on an AI software carbon intensity. So in terms of roadmap, all the features and are logged right now on the GitHub repository and accessible by anyone. I just want to focus on the near term and highlight a few of them. We're just about now to be done with an alternative approach, which is time-based calculation. And this one is very relevant because of the usage of analysis type of requests that are going to be using reasoning models instead of just pure simple conversations. Then I'd like to see in the near term more actionable tips. So right now there's only a comparison available with the number of miles driven, but obviously we want to have nudges and how to be more efficient if something is detected that seems to be wasteful. And also support of multimodal, which means generating images requires a lot more energy. And right now, the plugin supports only text-based, but I think having the ability to support images in the first time, eventually either video, audio, potentially, would be very important. So just to recap, I really hope that this will get you a sense that a plugin like AI Watch can be a very good option in terms of complementing the whole landscape of the ecosystem on estimating and measuring AI emissions, and has its place in terms of its impact as well. And I want to call to action anyone who wants to contribute. So I put the link here to the repository. I also encourage you to try AI Watch and provide some feedback. It's very important to get some feedback to increase user adoption of the plugin. Take a course. So I offer several courses on measuring and optimizing your AI to be more sustainable. So I put a QR code here for a new bootcamp I'm launching in June. I encourage you to sign up or be on the wait list. And finally, if you have any role in a company to bring changes from within and try to use tools like AI Watch to raise awareness within your company, within your team, whatever level of influence you have, is going to be very, very critical eventually to bring this to scale. So I want to thank everyone for listening to this presentation. And again, here, this is a QR code that gets you directly to the GitHub repository so you can start contributing to AI Watch. Thank you.